All right, let's talk about MLOps. It's a term that gets thrown around all the time in the world of AI and data science. But what does it actually mean? And more importantly, why should you care?
And this, right here, this is the heart of the problem. Seriously, this is where so many teams hit a wall. Building a slick model in a perfect, controlled environment is one thing, but getting it to work out there in the real world without crashing and burning, that's a whole different ballgame. So, let's break it down in simple terms.
First up, the model production problem. So what is this production problem we're talking about? Think of it as this giant, treacherous gap between a cool experiment on a laptop and a real system that has to work for millions of people 24/7.
Let's paint a picture. Imagine a team of data scientists at a bank. They've built this amazing fraud detection model. In their lab, with perfect, clean data, it's a rock star, catching 95% of all fraud. The team is celebrating, right? They think they're ready to go live.
But then, they push it to the live banking system, and suddenly, things start breaking. That perfect lab experiment just slammed headfirst into messy reality. The model that was so great on a single laptop just isn't cutting it with real-time, chaotic customer data. So what went wrong?
Well, here's a taste of what goes wrong in the real world. The data scientists built their model in Python, but the bank's main systems, they run on Java. So you can't just plug it in. The whole thing has to be rewritten from scratch. And then you find out it takes 3 seconds to process one transaction, which in banking is an eternity. Plus, the servers in production have different software libraries, different memory, causing all sorts of weird errors. And the real kicker? A month later, fraudsters have come up with new scams the model has never even seen before. That's called data drift, and it makes your model obsolete fast.
So that brings us to the big question, right? How do you possibly cross that huge gap from a successful experiment to a system that's actually ready for the real world? The answer, my friends, is MLOps. And to make this super clear, we're going to use an analogy. Next up, an unexpected MLOps analogy. Forget about code for a minute. Let's talk about something way tastier. Let's talk about a talented chef who makes the most incredible bowl of noodles you've ever tasted. Now think of the chef as our data scientist, and that perfect noodle recipe, that's our machine learning model. It's flawless.
So the chef decides to open a small cloud kitchen. At first, it's easy. 1 or 2 orders come in, the chef whips them up, no problem. It's all manual, and it works great. This is exactly like a data scientist running a model on their own laptop. Simple.
But what happens when you get successful? This is where we talk about scaling, from just a recipe to a whole system.
You see, as the noodle shop gets popular, it runs into a bunch of problems, and each one of these problems is actually a perfect mirror for the challenges that MLOps solves. Let's walk through it.
Okay, problem number 1. The shop is getting popular, 10 orders a day. But now the chef is running to the store for every single order to get fresh ingredients. It's total chaos, and it's just not sustainable.
So, what's the fix? The chef builds a real system. They get daily vegetable deliveries, monthly spice orders, everything gets organized. This isn't just about cooking anymore. It's about managing the raw materials.
The shop is a hit. We're at 50 orders a day, so the chef hires some help. But a new problem pops up. Customers start saying the noodles are inconsistent. Sometimes they're amazing, other times, not so much.
The solution? A standardized written recipe book. Every measurement, every step, every cooking time is written down. Now, it doesn't matter who's cooking, the noodles taste the same every single time. It's their single source of truth.
Now we're at over 100 orders a day. The shop's a local legend. But even with 2 chefs going full speed, they've hit a human bottleneck. They just can't make and pack the food fast enough.
So, the chef invests in tech, an automated cooking machine. You load the ingredients, punch in the recipe, and it cooks 4 perfect bowls at once. This is a total game changer. It's an automated pipeline.
Things are running like a well-oiled machine, but then sales flatten out. What's going on? Customers are getting bored. They love the noodles, but they want something new.
To fix this, the chef sets up a little R&D lab in the corner. This is where they experiment with new recipes, maybe a spicy version or chicken noodles. And crucially, they track everything. What worked, what didn't. This lets them innovate and find the next big hit.
All right, great story. But what on earth does a noodle shop have to do with machine learning? Well, this is where it all comes together.
Check this out. The inventory system, that's just data management and data pipelines. The recipe book, that's version control. The automated cooking machine is your CI/CD pipeline for deployment.
And the R&D lab is experiment tracking. Even monitoring customer ratings, that's model monitoring. See? It's the exact same set of principles.
And now, this official definition should make a whole lot more sense. MLOps isn't a single tool. It's a culture. It's a set of practices that connects the people who build the models, our chefs, with the systems that run them in the real world, the whole kitchen operation.
So why is this a non-negotiable? Why can't data scientists just toss their models over the wall and hope for the best?
Because it creates two totally different worlds. Without MLOps, you've got manual work, broken models, and zero visibility. With MLOps, you get an automated, reliable, and monitored system that can actually grow. It's the difference between a science fair project and a real business.
And this is not just some theory. It's how the biggest AI systems you use every day actually work. The reason your Netflix recommendations stay fresh is because of MLOps. Their models are constantly retraining on what you watch. It's why banking apps can catch new scams and why chatbots get smarter over time. MLOps is what makes AI feel alive.
Okay, that was a lot, so let's wrap this up with the final cheat code, the absolute key takeaways you need to remember.
And hey, if this is making sense so far, do me a favor and give this explainer a quick like. It really helps.
So here it is, 3 things to lock in. 1. Building the model is just the beginning. It's maybe 10% of the job. 2. MLOps is the essential bridge that connects that model to the real world. And 3. The whole system relies on automation, version control, and monitoring. You need the whole kitchen, not just the recipe.
And if you only remember one thing from all of this, let it be this. Machine learning only works in the real world when MLOps is strong, period.
So, I really hope that clarifies the why behind MLOps. In the next video, we're going to get into the how. We'll actually look at some of the real tools that make all of this happen.
If you like this content and you learned something from us, please subscribe to this channel for more updates like this video and share this video on all your social networks.